Light is photons, tiny particles shooting through space at light speed. This is what every physics teacher told you. This is what you learned in school. This is what everyone believes. Leonard Susskind says it's wrong, completely wrong, dangerously wrong. Light is not particles, not waves, not both. Light is something so strange that when you truly understand it, every light bulb, every rainbow, every star you've ever seen becomes a quantum mystery. Turn on a flashlight. Light comes out. Simple. You know what happened. Photons were created in the bulb, traveled through space, hit the wall, bounced back, entered your eye. You see light, photons, little particles of light, moving, traveling, existing. Leonard Susskind says stop. What you just described is fiction. Photons were not created, did not travel, did not exist as particles. The entire picture is wrong. Not a little wrong, fundamentally wrong, in ways that most physics professors won't admit because they don't fully understand it themselves. Let me destroy your understanding of light completely, then rebuild it from quantum field theory, the way Susskind teaches it, the way it actually is. First, photons are not created. The electromagnetic field exists everywhere, always, permeating all of space, in the flashlight, in the air, in the wall, in your eye, everywhere. This field is fundamental. The field is what's real. When you turn on the flashlight, you don't create photons. You excite the electromagnetic field, change its state, from ground state to excited state. The field was already there. You just changed its configuration, increased its energy, created an excitation. This excitation is what we call a photon, not a particle that exists, an excitation that propagates, not a thing, a disturbance, a pattern, a quantum of energy in the field. The field is the substance, the photon is the event, the happening, the change. Susskind emphasizes this relentlessly. Students want photons to be things, little balls, existing, moving. He tells them no. Photons are not things. Photons are what the electromagnetic field does when it's in certain quantum states, states with definite excitation number, energy quanta, not particles. Now watch what happens when the light travels. You think photons move from flashlight to wall. Susskind says no. The field doesn't move. The field is everywhere already. What moves is the excitation pattern. The disturbance propagates, like a wave on water. The water doesn't move horizontally, only vertically, but the wave pattern moves, travels, propagates. The electromagnetic field is the water. The photon is the wave. The water is stationary. The wave moves, same with light. The field is everywhere. The excitation propagates at light speed, but nothing is traveling, nothing is moving from here to there, just a pattern spreading through pre-existing field. This is not semantics. This changes everything. When you ask where the photon is, you're asking the wrong question. The photon is not located anywhere. It's a property of the field. The field has an excitation. The excitation is delocalized, spread out, existing as probability amplitude across space, not at a point, not in a location. Everywhere the field is excited. Before measurement, the photon is in superposition, not here or there, here and there, simultaneously. The wave function describes probability amplitude at every point. The photon is not at any particular location. It's distributed, spread, non-localized, quantum. When you measure, when the photon hits your retina, the wave function collapses, creates definite interaction, definite location. But before measurement, no location, no particle, no thing traveling, just field in excited quantum state, superposed, indefinite, probabilistic. Susskind says this is why wave-particle duality is misleading. Light is not sometimes wave and sometimes particle. Light is always quantum field. We describe it as wave when we look at field configuration. We describe it as particle when we count excitations. Different descriptions, same reality, neither complete, both partial. The field description is more fundamental. The particle description is derived, useful, practical, but not primary, not what's really there. The field is what's there, always, everywhere. The particle language is how we count and track field excitations. But the counting doesn't make particles real, just makes them useful fiction. Now consider what happens when light interacts. Photon hits atom, gets absorbed. You think particle was destroyed. Susskind says no. The field excitation transferred energy to electron field. The electromagnetic field returned to ground state. The electron field became excited. Energy transferred between fields, not particle absorbed. Field configuration changed. The photon didn't exist as thing that got destroyed. The photon was excitation that changed form, energy moving between different field types, electromagnetic to electron. The language of particle absorption is shorthand. Convenient, but not literal. Not describing actual process, not capturing quantum field reality. Same with emission. Atom emits photon. You think particle was created? No. Electron field de-excited. Electromagnetic field became excited. Energy transferred. Field configuration changed. New excitation in electromagnetic field. We call it photon, but nothing was created. Just field state changed. Energy redistributed. This means photons are not conserved the way particles are. You can create or destroy photons freely. Turn flashlight on. Create billions. Turn it off. Destroy billions. How? Because photons are not things. They're excitations, energy states, field configurations. These can change arbitrarily. Only energy is conserved, not photon number. Electrons are different. Electrons are fermions, conserved. You can't create electron without creating positron. Pair, creation, conservation law. But photons create and destroy freely because they're bosons, field excitations, not conserved particles, not things that persist, just temporary energy configurations in permanent field. Susskind asks students to feel this difference. Photons are not like electrons, not objects that exist, not particles that persist, temporary excitations in eternal field, coming and going, appearing and disappearing, as field state changes, as energy moves between fields, as interactions happen. Now add special relativity. This is where it gets truly bizarre. From photons' perspective, if it had one, time doesn't pass, distance doesn't exist. Emission and absorption are simultaneous. The entire journey from flashlight to wall to eye is one instant. Zero duration, zero separation, one event. But photons don't have perspective, can't have perspective. No reference frame exists at light speed. Photons are not observers, not entities that experience, not things that have point of view. They're field excitations. No perspective, no experience, no duration, no journey. What does this mean? Susskind says it means the photon picture is even more wrong than you thought. Photons don't travel through time, don't experience duration, don't go from here to there. From their non-existent perspective, emission and absorption are same event, simultaneous, not separated, one occurrence. The separation we experience is our perspective, our reference frame, our time. But the photon's world line is null geodesic, zero space-time interval. From universal perspective, photons' emission and absorption are same point in space-time. No gap, no journey, no travel. This destroys the picture of photons as particles flying through space. If the journey takes zero time from photons' perspective, if emission and absorption are simultaneous, then the photon is not traveling, not moving, not going anywhere. It's correlation between two events, emission event and absorption event, quantum connection, not physical motion. Susskind says this is what photons really are, not particles, correlations, connections between quantum events, the electromagnetic field mediating interaction between emitter and absorber, creating correlation, transferring energy, but not through particle motion, through field dynamics, through quantum evolution, through correlation structure. Now virtual photons make this even more strange. In quantum field theory, forces are mediated by virtual photons. Electromagnetic force between charged particles, exchanging virtual photons, constantly, uncountably many. But virtual photons are not real, don't exist even in the sense that regular photons exist as excitations. Virtual photons are mathematical terms in perturbation expansion, in Feynman diagrams, representing field interactions, not actual entities, not real excitations, mathematical tools. Yet they're necessary. Can't calculate electromagnetic force without them. Can't explain quantum electrodynamics without them. The math requires them. The predictions depend on them. They're indispensable to theory, but not real in any physical sense. Susskind teaches this carefully. Virtual photons are not photons that exist briefly, not particles that violate energy conservation temporarily, not things at all. They're terms in a calculation, ways of organizing perturbation series, representing field propagators, mathematical objects, not physical objects. The confusion comes from taking Feynman diagrams too literally. The diagrams show virtual photons as lines connecting particles. Students think the lines represent real photons, real things traveling, real events happening. But no, the lines are mathematical representations, calculation tools, not pictures of reality. Reality is quantum field, interacting, evolving, creating correlations. The virtual photon language is one way to calculate this evolution, one perturbative method. But the method is not the reality. The calculation is not the physics. The diagram is not the process. This means the electromagnetic force is not really photon exchange, not really particles bouncing back and forth. It's quantum field interaction, field correlations creating force. The photon exchange picture is classical intuition mapped onto quantum reality. Useful, intuitive, wrong. Now we go to the place that breaks everything you thought you knew about light. Because if photons are not particles, not things, not entities that exist and travel, then what are they? What is light at the deepest level? Susskind's answer is stunning. Light is not a thing. Light is information, quantum information, carried by electromagnetic field from one location to another, from emitter to absorber. The photon is the unit of this information transfer. One bit of quantum information, one quantum correlation, one piece of field-mediated communication. This is what photons actually are. Information carriers, not particles, not waves, not both. Information, quantum information, encoded in field excitations, transmitted through field correlations, decoded at absorption. The photon is the message. The field is the medium. The quantum state is the content. When you see light, you're receiving information, not particles. Information about the source, about what emitted the light, encoded in photon properties, frequency, polarization, phase. These properties carry information about emission process, about source characteristics, about quantum state of emitter. Your eye decodes this information, absorbs photons, triggers chemical reactions, sends signals to brain. Brain processes information, constructs visual experience. You see, not because particles entered your eye, because information reached your brain, mediated by electromagnetic field, carried by photons, decoded by neurons. Susskind connects this to quantum information theory, his current obsession. Everything is information. Space emerges from information. Time emerges from information. Even particles are information. The universe is quantum computer, processing information, storing information, transferring information. Photons are how the electromagnetic field transfers information, how quantum states at one location correlate with quantum states at another, how information propagates through space-time at light speed, maximum information transfer rate, causality speed, the speed at which information can spread. This is why nothing can go faster than light. Not because of some mechanical speed limit, because light speed is information speed, maximum rate at which information can propagate. Faster than light would mean information traveling faster than causal connections allow, violating causality, creating paradoxes. Physics forbids it. Light speed is information speed. Photons are information carriers. The electromagnetic field is information channel. All of this is information processing, quantum computation, universal Turing machine running physics, and light is how information moves in this machine. Now entanglement reveals another layer. Two photons can be entangled, quantum mechanically correlated. Measuring one affects the other, instantly, regardless of distance. This seems to violate everything about photons as particles, as things that travel, as entities with definite properties. But if photons are information, entanglement makes sense. The two photons carry correlated information, not independent messages. One message split between two carriers. Measuring one photon reveals information that determines the other photon's state, not because of influence traveling between them, because the information was always correlated, always shared, always one quantum state distributed across two field excitations. Susskind uses this to explain quantum teleportation. You can teleport quantum state using entangled photons plus classical communication, not teleporting particles, teleporting information. The quantum information describing a state, using entanglement as resource, using photons as carriers, using field correlations as medium. No particles move, nothing travels, just information transfer, using quantum resources exploiting entanglement. The photons don't carry the teleported state. They carry classical information about measurement results. The entanglement does the rest. Recreates state at destination. Not by moving it, by correlating it, by sharing quantum information through entanglement structure. This only makes sense if you understand photons as information, not particles, not things, information carriers, units of quantum communication, pieces of field-mediated correlation. Then teleportation is just clever information protocol, not magic, not paradox, just quantum information theory applied correctly. Now lasers reveal how wrong the particle picture is. Laser light is coherent. All photons in same quantum state, same frequency, same phase, same polarization. Millions of photons, identical state. How is this possible if photons are particles? It's not. If photons were particles, they couldn't all be in same state. Same location, same momentum. Pauli exclusion for fermions. But photons are bosons, can occupy same state, any number, unlimited. Because they're not particles occupying space. They're excitations of the same field mode, same quantum state of electromagnetic field, just with higher excitation number. Laser is electromagnetic field in coherent state, not superposition of number states. Coherent superposition with definite phase, definite amplitude, many photons, but all in one quantum state of the field. Not many separate particles, one field state with high excitation number. That's what laser is. Coherent field excitation, not particle beam. Susskind says students struggle with this because they learned photons are particles first, then try to understand lasers. Doesn't work. Coherent states make no sense for particles. But for field excitations, natural, obvious, simple. The field is in coherent state, high amplitude, definite phase. That's laser, nothing more. No mystery if you start from field perspective. Now, Hawking radiation demonstrates ultimate weirdness. Black holes emit thermal radiation, photons, coming from event horizon. But how? Nothing escapes black hole. Nothing crosses horizon outward. Yet photons appear. Thermal spectrum, real, measurable. The particle picture fails completely here. You cannot explain Hawking radiation with photons as particles, cannot explain how particles escape, cannot explain thermal spectrum, cannot explain anything. The picture breaks down completely. But field picture works perfectly. Quantum field near horizon, in vacuum state. But vacuum state is observer dependent. Different observers see different vacuum. Accelerated observer sees particles, where inertial observer sees vacuum. This is Unruh effect. Near black hole horizon, extreme acceleration, extreme curvature. The vacuum state far from black hole is excited state near horizon. Contains photons, real photons, created by gravitational field, by space-time curvature, by observer-dependent vacuum structure. These photons are real, carry energy, Hawking radiation, coming from quantum field behavior near horizon, not from particles escaping, from field excitation, from vacuum state difference, from quantum field theory in curved spacetime. Only works if you understand photons as field excitations. Fails completely if you think photons are particles. Susskind has spent decades on this. Hawking radiation, black hole information, holography, all requiring correct understanding of photons as field excitations, as information carriers, as quantum states of electromagnetic field, not as particles, never as particles. That picture is wrong, proven wrong, demonstrated wrong by black holes. Now the cosmological implications, light from distant galaxies, billions of light years away, red-shifted by expansion. You think photons traveled billions of years. Susskind says no. The electromagnetic field was excited at emission. The excitation propagated. But space expanded during propagation, the wavelength stretched, the frequency decreased, the energy reduced. Did the photon lose energy? No. The photon is field excitation. The field is in expanding space. The expansion changes field configuration, changes excitation wavelength, changes quantum state. The photon you detect is not the photon that was emitted. It's the same field excitation, but in different geometric configuration, stretched, red-shifted, changed by cosmic expansion. No energy lost to particle, just field evolution in expanding spacetime. The redshift is not Doppler shift of particle. It's geometric transformation of field excitation. Quantum state evolution in curved, expanding spacetime only makes sense from field perspective, completely confusing from particle perspective. Finally, the vacuum catastrophe reveals deepest truth. Quantum field theory predicts vacuum energy, zero-point energy, quantum fluctuations. For electromagnetic field, this should be huge, infinite actually, but we measure essentially zero. 120 orders of magnitude discrepancy, worst prediction in physics. The problem is treating vacuum as filled with virtual photons, particle language, counting particles, getting infinity, wrong approach, wrong perspective, wrong picture. Susskind says correct approach is holographic, information theoretic. The vacuum has finite information content, bounded by area, Bekenstein bound, not infinite, not filled with infinite particles, just finite quantum information, encoded holographically, on boundaries, not in volume. The vacuum energy is not sum of virtual particle energies. It's cosmological constant, geometric property of spacetime, information theoretic quantity, related to holographic entropy, to quantum information content, not to particle counting, never to particles. This resolves vacuum catastrophe, not by calculating carefully, by changing perspective, from particles to information, from volume to boundary, from quantum field excitations to holographic encoding. The answer is not calculation, it's reconceptualization, understanding what photons and vacuum really are. Information, not particles, information. Leonard Susskind has taught this for 50 years. Watch students struggle. Watch them resist. Watch them finally understand. Photons are not particles, never were, never will be. They're quantum field excitations, information carriers, correlation mediators, units of electromagnetic field dynamics. Light is not particles flying through space. Light is electromagnetic field in excited quantum state. The field is fundamental. The field is real. The field is everywhere, always. The photons are how we describe and count field excitations. Useful language, essential language, wrong ontology. Everything you learned is backwards. Started with particles, added wave nature, called it duality, but should start with field, understand field. See photons as excitations, as information, as quantum states. Then everything makes sense. Lasers, entanglement, Hawking radiation, vacuum energy, all make sense, all obvious, all natural. From particle perspective, all mysterious, all paradoxical, all confusing, because the perspective is wrong, the framework is wrong, the understanding is wrong. This is why everyone misunderstands light. They learned particle picture first, classical intuition, bullets and trajectories, things moving through space. Then quantum mechanics confuses them, wave-particle duality confuses them, nothing makes sense, everything seems weird. But start with quantum field, with information, with excitations, and light is simple, natural, obvious, no paradoxes, no mysteries, just quantum field theory, just information propagation, just correlation creation. Beautiful, elegant, true. Welcome to real understanding of light, where photons are not particles, where field is fundamental, where information is what's real, where everything makes sense. Finally, this is what Susskind knows, what he teaches, what he wants you to understand. Light is misunderstood by everyone, including most physicists, because the particle picture is too seductive, too intuitive, too wrong. Let it go. Embrace the field, understand the quantum, see the information, and light will never confuse you again.